Hello, everyone, and welcome back to TechInsights, the Chip Observer, a podcast on semiconductor insights. Today, we're looking at the continuing saga that is AI, exploring manufacturing capability, capacity limits, and export policies shaping the global balance of AI compute and its future infrastructure. Today's episode is about what TechInsights calls geographical AI compute power. The very real question of how much AI compute different regions can produce and what's limiting them. AI gets talked about a lot, like it's software magic. Models, prompts, breakthroughs, but every once in a while it's worth zooming out. And then zooming all the way back in, just so we remember that AI is still grounded in something very physical. Things like silicon, factories, yield curves, and policy constraints. Note, this is built off a recent TechInsights webinar, companion articles, and so on. A discussion held between industry specialists and analyst Dan Kim, Eric Bellosier, and Anand Joshi. But this isn't a replay. It's a guided conversation, pulling out the most important ideas and adding context along the way.
We spent a lot of time here doing something that very few organizations can actually do. We actually opened the chips.
That was Dan Kim, Chief Strategy Officer at TechInsights. He recently moderated a webinar regarding this topic exactly. And one thing that immediately stood out in this discussion was how much emphasis TechInsights places on physical evidence.
We do the physical analysis, we do our teardowns, we do process node verifications, among many other things.
Not vendor claims, not roadmaps, but actual chips, torn down, measured, and verified.
And that ground truth is what anchors everything that we do here and everything that you're going to be hearing today.
And that's an important framing, because once you ground AI discussions in what can be manufactured, the conversation changes. Suddenly, access to lithography tools, packaging know-how, and process maturity matter just as much as model architecture. From there, the conversation naturally turns to the widening gap in AI compute, especially between the US and China. For example, we have NVIDIA on one side working at the cutting edge with TSMC, advanced packaging, and high bandwidth memory. And then there's Huawei on the other side of things, facing a very different set of constraints. And this isn't speculation. It's based on what's physically observable.
NVIDIA still holds a significant lead. The gap is meaningful. The difference in raw compute is about 4x, and we expect it to grow to about 6x.
That's Eric Bellosier, top-tier semiconductor market analyst. And what he's saying gives us a clear sense of the size of the gap. But a more important question is why that gap continues to widen. That answer lies less in ambition and more in technology access and manufacturing maturity. And the reasons aren't mysterious.
There are many reasons why Huawei and other Chinese players, for that matter, will have a hard time catching up. Mainly TSMC technology node is shrinking from 4 to 3 to 2 to maybe 1.5 nanometer, and NVIDIA has access to more advanced packaging.
So, faster node transitions, better packaging, and a memory ecosystem that simply scales better. Now, here's where the conversation gets especially interesting. Because capacity alone, that's how many wafers a foundry can produce, doesn't equal compute. Yield matters a lot. And AI accelerators are huge chips.
So at 800 millimeters square, you're almost down to 0% or 1% of yield.
That was Anand Joshi, veteran AI semiconductor analyst. And 1% yield on massive data center dies changes everything. At that point, the question isn't just performance. It's whether large accelerators are economically viable at all.
We don't see them achieving the same yield as standard reference processes like TSMC, and so stay significantly lower than the industry standards.
So, we're seeing a strategic pivot come up again and again. If you can't win on raw performance, you play a different game.
And so they will have to produce much more chips just to keep up with the compute power needed to compete, and also needed for China AI needs, basically.
So, based on what the modeling shows, it looks like China's path forward isn't about matching NVIDIA chip for chip, but focusing more on scaling differently. We're looking at more chips, smaller dies, chiplets, and advanced packaging. Less about peak flops, that's floating point operations per second, and more about system-level throughput. One of the most nuanced parts of this conversation is export controls. And here, the evidence points in two directions at once. Export controls are limiting access to advanced tools, but they're also forcing innovation.
Two observations to speak to a broader policy debate, if I may. For those who argue that export controls are working, the evidence does support that. The lack of access to advanced lithography equipment has demonstrably curtailed SMIC's ability to produce below their ambitions and below 7 nanometers and successfully yield market-relevant AI chips that scale. That is clear. And for those who argue that export controls have led to unintended consequences, spurring innovation in the Chinese market, the evidence supports that too. That multi-patterning of DUV equipment, aggressive advanced packaging in smaller die sizes than otherwise would be commercially rational, and AI models engineered to extract frontier performance from far less compute.
So what we're seeing is that even though there is a limiting access to advanced tools, it's still forcing innovation with multi-pattern, aggressive packaging, and model efficiency. Constraint doesn't stop engineering. It reshapes it. One of the clearest conclusions from this discussion is that China isn't chasing the same definition of AI leadership. The focus is shifting toward inference, lower precision compute, and real economic return.
So we expect China to play a different game. We see local capacity to be optimized for inference, where the money is made, and also where more nimble chips can serve customers as well, or maybe even better than fewer larger chips.
If there's one idea to take away from this conversation, it's this. AI leadership isn't just about models. It's about yield curves, packaging ecosystems, manufacturing maturity, and policy constraints. So what's the takeaway here? When we look at the realities on the ground, China's path to competing in AI compute isn't about catching up chip for chip. It seems more about scale, pragmatism, and adaptation, building more fabs, improving yield through smaller chips and advanced packaging, optimizing models for less compute, and finding alternative paths to memory bandwidth and access. Constraints are real, but they're also shaping different strategies, different models, and different outcomes. The gap matters, but how that gap is navigated may matter even more. I want to thank our analysts for sharing their thoughts on these ever-evolving innovations. None of this would have been possible without their research, notes, and insights. Please note the contents discussed here today were for informational purposes only and don't reflect views or opinions of the institutions or organizations mentioned. And again, this episode was only a glance at a broader analysis published on our TechInsights platform, both as a report and on-demand webinar. One final quick disclaimer. Although this episode was enhanced using AI, the script, editing, and production were all realized by a real human being. So, as always, be sure to follow us, subscribe for updates, and explore more in-depth analysis at TechInsights.com.